Is this the most successful animal ever? A procession of segmented creatures moved across the seafloor. Overhead, hundreds have begun shedding their exoskeleton and piling on top of one another in what appears to be a massive orgy. But this is not the same alien world. It's ours about 500 million years ago, when these creatures called trilobites prospered, prevailing for around 270 million years and encompassing more than 2,000 distinct species. Trilobites are some of the most successful life forms in Earth's history. When they spring into existence, they are among the diverse and sophisticated organisms Earth had yet seen. And as the earliest known animals with the complex eyes, trilobites had a unique perspective on its ancient world. For almost all of Earth's history before the rise of the trilobites, life has mostly consisted of microscopic marine organisms. But then, scientists think an increase in oxygen allowed the multicellular life forms to extract more energy from their food and perform more complex functions. This then enabled the rise of carnivores, which in turn spurred a productive arms race, resulting in what's known as the Cambrian explosion. Within about 20 million years, life has branched out to include most of the animals we know today. Trilobites were an important part of this surge. All trilobites have three lengthwise lobes, but building off the same basic components, they vary greatly. Species ranged in length from a few millimeters to almost 1 meter, and some were equipped in trigger ornaments. As a result, they filled many distinct niches over the ages. Many trilobites plow or burrowed into the sea floor, while others swam freely. Certain species had spines, horns, and even protruding tridents, and their social behavior was complex. They came together to search for food, find safety in numbers, migrate, and mate. In fact, their fossilized congoli represent some of the first evidence of animal group behavior. Like modern arthropods, trilobites have compound eyes composed of many tiny lenses, but theirs were made of the minimal calcite, which also constitutes their exoskeletons. These lenses allow trilobites' form to share images and quickly sense changes in light. Some had long eye stalks and helped them peep above the muddy sea floor as they brought beneath. Others had large dragonfly-like eyes, but they probably used to scurry the ocean bottom as they swam upside down in damp waters. And some trilobites have fluid-like eyes that may have offered 360 degrees views along with structure that provide shade from overhead light. That despite their dominance of the sea, trilobites were vulnerable to environmental changes and predators. About 444 million years ago, Earth cooled and sea levels dropped, radically changing some of their habitats. This was the beginning of what would improve the trilobites along the mine. Some 20 million years later, fish and jaws began sweeping the sea. Trilobites developed spiky termination and neat ways of locking their joints shut. Many species could carve themselves into the ball, entirely sealing their soft part inside their hard exoskeletons. Then, another extinction event shocked the world. Trilobite diversity dwindled and come about 360 million years ago. Only one of the 10 former trilobite organs remained. Finally, rapid climate change spurred the greatest known massive extinction ever in Earth history. This catastrophe carried the finished trilobites off, along with approximately 96% of all marine species. But the trilobites left a remarkable reward behind. The calcareous exoskeleton made for hardy fossils that would remain intact for hundreds of millions of years to come. We found a trilobite fossil on every single continent, many in unlikely environments that were once part of the ocean floor. Trilobites have no direct descendants, but their evolutionary cousins are alive and well. And since arthropods make up over 80% of current animal species, we might say that although Earth may no longer be the planet of the trilobites, their distant relatives still remain supreme. One more. A procession of segmented creatures moved across the seafloor. Overhead, hundreds have begun shedding their exoskeletons and piling on top of one another in what appears to be a massive orgy. But this is not some alien world. It's Earth about 500 million years ago, when this creature called trilobites prospered. Prevailing for around 207 million years and encompassing more than 2,000 distinct species, trilobites are some of the most successful life forms in Earth's history. When they sprang into existence, they were among the most diverse and sophisticated organisms Earth had yet seen. And as the earliest known animals like complex eyes, trilobites has a unique perspective on the ancient world. For almost all of Earth's history before the rise of trilobites, life had mostly consisted of microscopic marine organisms. But then, scientists think an increase in oxygen allowed the multicellular life form to extract more energy from their food and perform more complex functions. This then enabled the rise of carnivores, which in turn sparked a productive arms race, resulting in what's known as the Cambrian explosion. Within about 20 million years, life has branched out to include most of the animal groups we know today. Trilobites were an important part of this surge. All trilobites have the three lengthwise lobes, but building off the same basic components, they vary greatly. Species range in length from a few millimeters to almost 1 meter, and some were equipped with the trigger ornaments. As a result, they filled with many distinct niches over the ages. Many trilobites float or burrowed into the sea floor, while others swim freely. Certain species have spines, horns, and even pro-drilling trilobites, and the social behavior was complex. They came together to search for food, find safety in numbers, migrate, and mate. In fact, their fossilized conga line represents some of the first evidence of animal group behavior. Like modern arthropods, trilobites have compound eyes composed of many tiny lenses, but theirs were made of the mineral calcite, which also constitutes their exoskeleton. These lenses allow trilobites to form two sharp images that quickly sense change in light. Some have long eye stalks that help them peep above the muddy seafloor and the seafloor beneath. Others have large dragonfly-like eyes, but they probably used to scour the ocean bottom as they swim upside down in the damp waters. And some trilobites have pillar-like eyes that may have over 360-degree views, along with structure that provides shade from overhead light. Yet despite their dominance of seas, trilobites were vulnerable to environmental changes and predators. About 444 million years ago, Earth cooled and the sea levels dropped, radically changing some of their habitats. This was the beginning of what would prove to be the trilobites' long demise. Some 20 million years later, fish with horns began sweeping the sea. Trilobites developed spiky articulation and neat ways of locking their joint jaw. Many species could carve themselves into the balls, entirely sealing their soft parts inside their hard exoskeletons. Then, another extinction event shook the world. Trilobite diverse dwindled and come about 360 million years ago. Only one of the 10 formed trilobite order remained. Finally, rapid climate change spurred the greatest known massive extinction events in Earth's history. This catastrophic series finished the trilobites off, along with approximately 96% of all marine species. But trilobites left a remarkable record behind, the calcium exoskeleton made for hardy fossils that would remain intact for hundreds of millions of years to come. We found trilobite fossils on every single continent, many in unlikely environments that were part of the ocean floor. Trilobites have no direct descendants, but their evolutionary cousins are alive and well. And since arthropods make up over 80% of the current animal species, we might say that although Earth may no longer be the planet of the trilobites, their distant relatives still reign supreme.